Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on my fourth interpreter in Go. So right now we have a good amount of the code implemented. So we have support for all of these different things, which it's actually easy to tell what they are down here. Yeah, so we can add, subtract, do all the arithmetic stuff, including modulus. This is for comparison operators. Yeah, we have and, or, invert, all that stuff. And we actually have enough to write hello world, assuming you know the ASCII table values, of all the things. So I pulled that up in here, and then I wrote this little program. So this is H, obviously, and then we omit it, and that essentially means we're printing the ASCII value of it. So if I go ahead and run this, may not go, on test.forward, then we get hello world. So this is hello world. But that's not necessarily the way you're supposed to do it in fourth. If we look over here, yeah, so there is ways to print strings, where you do dot slash, and then does that. So it has to be defined in a word. You can do hello world, and then you can type out your string. So you can say hello world, like that. I don't need the new line. And then you put another space, and then close parentheses, and then also a semicolon. And then we define the thing. So we can type hello world, and it will actually say hello world. And you can also do it with a line break if you want that. Yeah, hello world. There we go. So that's how you're supposed to do it. But we don't have support for that yet. So I'm going to work on that. But first, if statements is something that we were working on yesterday, that we didn't quite finish. So if we look down here in conditionals, we have, if I can find it, if. Yeah, so we have if. So we can do stuff like this. It's gone now. Okay, yeah, we can do things like this, without the strings, obviously. Where you do if, and then if the top of the stack is true, then it will execute this. If not, it will just skip over it. We don't have else. So that's basically what I need to implement now. So, alright, yeah, so something like this. So basically, yeah. So just something, right? I'll call it foo, I suppose. Foo, and then we can just push 0 onto the stack. So that means false. And then if, yeah, so if top of the stack is true, then it will do this. So just push 10 and print it. Else, it will do this. So it'll print 12 and print it. And then you type then, and that is the and keyword essentially. And then you type one of those. So this won't work right now because we don't have else. Yeah, and then you just call foo, and it will print 10 or 12. So that is essentially what we have to do. Go run, may not go on test.forth, and yeah, it doesn't do anything. So we don't really have error handling right now, but we will get to that. So basically, we just need to add here else type, and then we can go down here and actually lex that right here, else. There we go, and we can else type right there. So that is what we need. So it shouldn't be too terribly difficult to implement. So we have right here, let's see, it's down here. So we have if type, and then type we're actually not handling anything. So let me just do one of these, because we should not encounter. Yeah, there we go. Okay, so here you have to be in a word for it to work. So that is what we have here. So let me add the case for else type. And then for now, yeah, I will just continue. I can type continue. There we go. Yeah, so that is what we want. So basically here, right now we're checking, well, it is this, or now that category does not equal, actually it needs to be and, does not equal else type. So we'll go through this until it is one of those. Okay, yeah, so when one of these is true, then it will execute this, or it will stop executing this and not skip anymore. So if it is false, then we'll do that. Yeah, and then in here, I think we need to do actually minus minus. So we just need to subtract 1 from it so that we do actually get the else. Is that necessary? Let me see. So if we don't do that, what happens right now? Go run, may not go. That's not forward. And yeah, I should not encounter it. So we get to a then type. Yeah, so that is something that we need to handle in here. So if is word, else we need to do the log.fatal thing. And let me actually add should not encounter else, and then this can be should not encounter then, because we should not encounter that. We should skip over it. Yeah. Okay, so I can get rid of this continue here, and let me actually close out of this because it's distracting. So basically, yeah, I think we're gonna need to do an I minus minus in here, and then we'll get into here, and we can basically do the same thing that we're doing here, except for the else. Yeah. So if I just go ahead and yank that, then whoops. Okay, so this we won't encounter another else. I don't think. Can you actually stack else's? So let me just do foo, and then 0, and then if. No, you wouldn't be able to stack else. No. You can stack if else. Yeah. That was just alright, so we don't need another check for else. Okay. And then we can do that. But the thing is, we don't want to do I minus minus actually for this. Maybe we don't need that. Let's see what actually happens. Whoops, that's not what I wanted to do. Go, run, main not go, test not full. And should not then. Okay, so we do encounter then. So maybe we just need to skip over it for now. And then we can handle stuff. So we get 0. So that is not what I wanted it to output. Let's open test not forward. So why does it output 0? So does it not push this onto the stack? Is that the issue? Is that the issue? Let's do 1. We do get 10 then. So if it's true, it does that. So the else seems to not be working. Okay. So we get 0. So. Actually, I think we need to do this. Yeah. But I didn't actually check. No, because we don't need to actually check. Because. Ooh, maybe we do. Because, so if we do not, if it's false, well, so if it's true, then we execute that, but then it also tries to execute the else. It doesn't, well, no, it never tries to execute the else. So that is the issue. So basically, yeah, we can actually, we can do this, and then we basically need to do it the opposite way. So if it was false, because it doesn't actually pop it up, you can see here, it just peeks it. So if it's false, then let's see, if it equals 0, then we can do this. There we go, and then indent that, and then here, actually, I'm going to change this, get rid of that, then there we go. Okay, so now if I run it, it still is 0. Okay, so if A is 0, then we skip over everything. No, if A is not 0, there we go. So we still get 0. So, yeah, so if it is not 0, then we want to skip everything. Otherwise, we want to actually execute. So, yeah, so I'm not sure exactly why it's not working. Let me change it to 1 again. Then run this, and we still get 10. Let me do CR as well. Okay. So yeah, we run that, we get 10. But if it is 0, we get 0. So why does it... Let's see. Let me print... let's see. Format.print1 A. And let's see what A is. It doesn't actually print A. So, so we never actually get to the else. Define A. Yeah, okay. So, whoops. Okay. Then we get 12. Okay. Yeah. So we did need to de-iterate it, essentially. Alright, so let me actually make that to 1 again. And we get 10, just 10. 10 to 0. And we get 12. Okay. So it looks like, to me, it is working. So I think we have if else then. So I think I'll add strings before I do the loops. Does need further testing, but this basic testing at least it does work. So now, strings. So you're gonna do something like that, and then you type in the string here, and it will actually output that. So you put a dot and then quotation mark, and then a space in between it. That is important. And then you type out the string, and then another space, and you put the close parentheses, or quotation mark rather, and then another space and the end of that. So that is sort of what we need to parse. So if I run it now, it doesn't. Let's save it. If I run it now, it doesn't do anything. So let's add. Let's see. I think. Let's see. What is it called? So let's see. I want this one. Generating output. Yeah. So what is that? Special word for outputting string. So this can be print stir, I suppose. So we can go actually right here. Print stir type. Maybe just print stir type. Yeah. And then we can encounter it here. So after the print, where is print? Print, and that is where? I don't know where it is. Hang on. Oh yeah, it's just a dot. I'm stupid. Okay. Yeah, it's just a dot. It is not anything. So it's up here somewhere. Yeah, this, maybe I'll move it down here actually. So it is actually in a better order. So I think I can put it right here, right there. There we go. All right, and then we'll add case for dot quote. So we do need an escape character here actually. And then token dot category equals print stir type. Just like that. So then we have the print stir type. We also need one for just the quote. So that can just be called a quote type. Let's see. It could probably go right around here. So quote type. Is there a better name for that? No, quote type is good. Okay, and then that I'll actually put right after this. Case of that. Then token dot category equals quote type. There we go. All right. So. Yeah, so it should be able to lex it all now, if I run that. It doesn't, we don't actually, let's actually print all the tokens. So for, let's see, val, it's actually, let's see, val, range of tokens. Then I will basically just format dot print line, val. Val dot value is what I want to see. So, I need to actually do something like that. And there we go. So we get all that. So we get the string. So we do, that did work. Okay. Right now they're being set as words though, but it doesn't really matter what they are considered. So in here, we do need to check if they are, if it is in a word, because it can't be defined out of a word. So if I do something like hello world, then it will not actually work. Yeah, hello world action is not a function. Actually, let me get rid of that. Maybe it does work. Oh, okay, maybe it does. Yeah, so it doesn't actually need to be in. I'm not sure why I thought it was. Yeah, so it can be defined anywhere. So that actually does make it a little bit easier. So print type. So case print stir type. So once we encounter that, we want to start collecting the string essentially. So I will continue for now. And then I'll add the other type also. So quote type. Continue as well. So we need some way to, like, basically a buffer that we append the string to as we encounter it. Yeah. Okay. So I think we might need to change our lexer as well, because if we encounter a keyword within here, it's not going to give it a value. So we need to, yeah, we need to actually do this for all of them. Okay. I think we can just do that in the loop. So if I do something like that, okay, maybe it actually has to go down here, and then I can get, well, actually, it doesn't really matter. But then if I print them all, so in range of tokens, and then format that print line, and I print the val.value, then it should print the whole thing out. Yeah, so now they all have that. So that way we can get the keywords. Because if I don't do that, we don't actually have the keyword in it. So that is the point of that. Okay, so I think that'll be fun. And that shouldn't break anything. So, yeah. So the string. That is what we are trying to get. So basically we need a string buffer. Which all this I'll separate into, like I'll collect it all into a structure once it is mostly implemented. So this will be a string buffer and it's just a string. Okay. So if we encounter this, I passed it. If we encounter this, we want to just keep iterating through while it is not that. So basically, yeah, so we can use a for loop to do that. So we can do for, let's see, for I, while, let's see, what is the val does not equal, a, val that category does not equal quote type, I plus 5. Okay, and then we will basically append to, so how do you append to a string in, actually we can just do plus equal, so we can do, but then at the end we want to set it to none. Okay, I think we can do that. So let's do, let's see, string buffer plus equals val dot value. And then also we need a space in between them all. Val dot value plus that. Because it's all going to be space separated anyway, because that's how we actually split it. So we know that it's going to be a space, so that should be fine. And then we can do format dot print string buffer, and then string buffer equals none. Yeah, something like that. I is not used. Yeah. Actually, I need to set the val equals, let's see, what do I set it to again? Val equals tokens I. Yeah. Tokens I. Right. I don't know. That still doesn't work. Yes, we need to use index like that, 0. We can still do I plus plus though, I think. I think that should be fine actually. Index declared not used. I plus equals index. Okay. So it didn't actually do anything, so it didn't work. Did we encounter this? So let's just add a statement here, and let's see. So we don't ever actually get there. So we're not setting something properly. It's because of this. Okay, no. So we don't have the print stir type in here. We did define it here. And we do have it here. So maybe I messed up the escape character. Well, let me do. Let's see if we make it here. Okay, so we do get there, and we set it equal to that. Let me do this and that, and see if it does. Alright, so that is all still working. So is the quotation mark not working then? Let's see. Like that. No, so that works. But then when we get out of here, it doesn't work anymore. So we're not setting anything here. Yeah, it doesn't want to work. So, do we get here? No. Alright, so we don't get to any of those. We don't get here either. So, what is the deal with that? Let's see. Does it recognize something else? It does not. So, might have broke something. Okay. Do we just... So when we encounter a word, then we do this. So do we actually get here? Let's see. So we do get that. So we do go back through and interpret it. Uh-huh. Okay. So let me get this stack. Is the issue something to do with the string buffer? Okay. So the tokens that we pass are the tokens that we collect in there. So words value. So in here, are we not collecting it properly? It's word type. Let's just print val.value like that. Let's see what we get there. So we do get all those. But we don't collect the things in between them. Ooh, because they're word types. Ooh, okay. So that might be the issue actually. So maybe, in here, we need to also check if we encounter a word, and then append that. Yeah, okay, I think we can do that. So we can do else if val.category equals print stereotype. Then we're going to, well, right now we'll just print that out and we'll get that. Okay, perfect. So then what we want to do is essentially the same thing that we're doing down here. Right here. Except we want to just append it rather than skip over it. So, oops. There we go. Okay, so we print it out. We don't need to do that. Then we can do this. Let's do I plus equals index, and then we just want to append the next one. So let's append word tokens and then val, because we're sending val each time. So that should be fine. And we don't need that. So then now if I run this, we do print out, we almost print it correctly. So we don't want to print these ones. So that is actually the issue. So on the last iteration, we don't want to append it. Alright, so basically, here, we want to do I plus 1. Let's see, maybe not that. So the first one needs to be, let me do I plus equals index, like that, and then run that, and okay, so that doesn't work. Oh yeah, because we're actually iterating it too many times. So that will work if I get rid of that. So now we basically need to check if it is one of these, and then not append it. But we do know that it's gonna be the first and last. So maybe there's a better way of doing that. So the first one, on the first iteration, we could just do I plus equals 1. Could do that. Maybe just maybe I'll just add checks for now, and then I can get rid of that. Actually, we need to do if val.category equals print stereotype. And maybe this should be if tokens I plus 1 dot category. Well, it's not that, because then we don't need to handle that. But then if it's a print stereotype, yeah, basically if it's not, then we want to do this. There we go, and that I think should solve the problem. No, so then it broke. Stack underflow. So let's see. It's not because of that. So what is causing a stack underflow? Okay, so now it doesn't print anything. So that's not good. Let me get rid of that then. Let's do that, and then Yeah, now it's not doing anything, so I think I broke something. What did I do? I broke it. Yeah, this needs to be val, I guess. No, it still doesn't work. So, I don't know what I did now. Let me undo all this, just going back to how it was. And I'm pretty sure it was the same thing as what I just had there. So, alright, yeah, it doesn't work now. So, what happened? The string. So, I don't know what happened. Let me get rid of that, actually, and do it just in here. Like that. And we do print that out. So, that works then, but now it doesn't work in the word. So I don't know how I broke it now. In here. Let's see, now dot value. Okay, so we get all that. Okay. Ooh, but we're not appending the last one. So, why is that? Now that's gonna go forever, so we don't want that. Let's just do... Let me try that. And then, yes, we still don't get that. Let me think it after that. And we do, actually. So, yeah, that's fine. So that's not what the issue was. So let me move that back. So we do get that. Now it gets stuck forever. Because index is 0, so I need to get that. Okay, so now that value here, we get all of those. Yeah. So that should be fine. We're appending that, and we're skipping over them as well. So I don't know what the issue with that is. Let's also print the... Let's print the current word when we are here. And see what we get for that. So we just get food, so that is fine. Okay. So, I don't know why. Let's see. Do we ever get to the print statement? Let's see. So we don't get here anymore. So, is it not calling it properly? I don't know what happened. It was actually just working a minute ago. Did I type something wrong? Let's see. So, how you define it? Let's see. Say hello. Hello there. Okay. So we don't get here anymore. So we're not appending it properly. What is the problem? What is the issue here? Because we are going through each one and appending it. So I don't know. I don't know. So we're getting here, but it's not setting the word tokens proper. Alright, so we get a stack underflow when we do that. So but then it does print. Okay. So we need like an extra token in there, I suppose. So we're iterating it one too far. Is that what the issue is then? Because, oh, we're grabbing the declaration of it? Ooh, okay. That could be it. Okay. Get rid of the 10. Alright, then it prints it out. But does this break things? Maybe. Let's see if we help through again. Then, okay. Yeah, we print it twice. So that actually is probably fine. Yeah. So we just had to decrement that. So that looks good. So now in here, yeah, we just need to check if val.category equals printster type, then, yeah, we'll do not equals. Then we'll append that. Okay. Now we got rid of that. So here, if tokens I plus 1. And now it doesn't print anything, so that didn't work. So, okay, so let's do that. Let's just do this, and it is not that. So that category is not quote type. Then we'll do that. And then we get test and test. But there is a space after it. So why is that? Oh, because we append a space to the end of it. So maybe we want to append it actually at the beginning. Well then that's going to put a space at the beginning as well. So maybe I need to expected. Oh yeah, I need to plus like that. Okay. So yeah, that won't work like that. Oh, because I'm doing that. So, yeah, now that just puts space in the beginning. So I think maybe we can use printf. And we can do that, and we can do this, let's see, string buffer, and then val.value, something like that. No, okay, so that doesn't work. Maybe we need to actually set the string buffer equal to that. And then, yeah, so it's still the same problem. So, yeah, so we just need a way to separate it by spaces. But not on the first iteration. So, what is a good way of doing that? Let's see. Okay. So to do that, alright, well this can just be, we don't need to use the sprintf, so that's fine. It's value. So if I do that, then there's no space, and it does that. So, if, yeah, we don't really, maybe we need the index to just be plus plus, something like that, index plus plus, and then we can just do I plus plus at the end of the iteration. And then, yeah, we can just check if index equals 2, then we just want to do this. Otherwise, we want to append a, it's probably a better way of doing this, but for now, append a space like that. And then, okay, yeah, so that did actually work. So if we do a new line after that, after both of them, then it will print it with a new line and properly spaced. Yeah, let me clear because that other one above it is looking kind of weird. There we go. Yeah, so that is good now. So I think we have support for strings now. So if I just do that, and then hello world, and then do a CR like that, I think. Hello world. Okay, so that is not right. Okay, so what do I need to do to fix that? Why are we appending it twice? Ooh, okay. We need to add an else here. There we go. And now it shouldn't do that. Hello world. Okay, perfect. It doesn't recognize the CR. So I think we need to do I minus at the end of it. There we go. Okay, so yeah, because we just skipped one too far on that. So that is pretty good, I think. Yeah, so now we can print hello world a bit more properly. So this is essentially equivalent to what I was looking at the beginning. Yeah, so we can now, let me just do a bit of testing. So hello world, like that. And then hello world, and put a CR in there, and go ahead and do that, and call hello world, and it should print hello world. Perfect. That is superb. Okay. So. It's not like pretty or anything, but let's see. Do we actually get here? We might because we decrement. So we don't. Okay. Yeah, okay, so I guess we are good here to do that. So, end quote. Just, so that will just provide a bit of error if you just put a quote or whatever. Like this, so if you just put something like that, then, actually that's not even gonna give us the error. Because it's double, so we need to separate them, like that, and then we'll get an error. Yeah, error and quote. Okay, so that is all good. So, now we actually have strings, so that is something that is pretty good, actually. We are getting close to implementing most of the stuff on this page. So now we can look at loops. So we have if then. We also have if else then. So do loop. Yeah, so you can do this using a loop. Let's see, buzz, fuse buzz. Alright, so let's look at the syntax of a do loop. Is there other types of loops though? So, then we gotta get to variables. So it looks like that is the last loop that they show in here. Yeah, let me actually commit what I have here because it is pretty good. So I'll just put a hello world in here. And then just gonna double check, make sure it works. Okay, good. So I will commit that. Added else statements as well as string literal print. There we go, and I'll post that. And there we go. So that should be up in the repo now. And there we go. Okay, perfect. So, may not go. So now, now indeed. So let's see. So, yeah, do loop. So what keywords does that actually add? Let me see. So do for loop. Okay. Special word I pushes the current loop index onto the stack. Okay, so we need to keep track of the loop index. So there is two keywords. There's I and do. Okay, so that is looks like it's what we need to do. So we can handle that pretty easily. So let's see. After the if, then we'll do type as well. And then not drop. Do type as well as I type. Because that is the current index and the do. Let me open the test.forth and actually implement a do loop here. So, do they need to be in a word? Let me actually try that. So, do I, let's see, I don't know how it works exactly. So, let me just copy this and let's try to figure it out. Do I, and there we go. So that will just print it out. Or, whoops, it's dash. Okay, so that prints that. So, this is the index, I suppose. And then the 0, I'm not sure exactly what that is. That is just, oh, that is the starting index, I suppose. Okay, so, so it just compares. All right, the top two values on the stack, given the starting value and ending value. Okay, starting value is taken from the top of the stack. So that's the starting value, and this is the index to compare it to. Okay, okay. And this is just what goes on in here, so we can just print 10 every time. Okay. So, yeah, let me just add that test. So, wait, actually, I wanted to see if it works outside of there. So, if we do 10 and 1, and then do I, dot, then it will print, yeah, so it doesn't work. So, it looks like it needs to be in a word definition. I loop. Yeah, okay, so it doesn't seem to work outside. So, alright, so do I. Okay, actually, we need one that says loop as well, right? Yeah, so loop. Okay, yeah, so I need to add a loop keyword as well. I forgot about that. So do type, loop type. And then it has to be in a word definition. So we just have a foo here. and then we'll push the number of iterations, the starting index, and then do, this pushes the index to the top of the stack, and then we'll print it out, and then we have drop, or not drop, sorry, it is loop, and then the end of the declaration. So if we call that, it should do, print the index each time up to 5, well, up to 4. So, now we can parse that, so that should be pretty easy. So after the if else, then we'll do and then set the token category equals do type. Okay, just like that. And then in case of loop, actually, case of loop, token category equals loop type. And then in the case of an I, token category equals I type. So that should keep track of all those. Now we can add support for them in here. So it's going to be quite similar to the if statement. In some ways, I guess. It's not really a conditional loop though. So so this can just be, this is basically just a continue, I think. But I will just put nothing there for now. So let's do type. Let's see, loop type, and then case I type. So with the do type, we have to be in a word. So if is word, then we'll do stuff. Else we will do log.fatal. Should not do. Okay, and then in the loop type, let's see. So we are just going to let's see. So we're going to do this. And then I think we should make a struct for this. So make a struct. Type loop struct. And this needs the current index, which is going to be an int, and then it also needs the target index, which is going to be an int as well. And I think that is all we need. So then we'll make a new loop object, or a struct rather, and then we'll set the current index equal to the top of the stack, and then we'll set the target index equal to what is just below that. So really quickly, if I go ahead and drop all these, drop, and then let's see, copy that in. Okay, and then if I do a loop, so if I do something like this, push 10 and 1, and then do, and try to print, then does it pop off the stack? Essentially is what I want to know. If I call foo, alright, I think I broke it. Okay. It's not responding now, so that is not good. Let me copy that and see why I made it an infinite loop. So it's not what I wanted to copy. I can't select it. There we go. And now, so we have this. So that is the index, right? Starting index. So do you need to use I? So perhaps, because if we had I to that, then it doesn't. All right, so we need to use I in the loop. But it doesn't say anything otherwise. All right, but that's fine. So we can basically set the current index and the target index pretty easily. And I think we need to pop off the stack. So I will do it popping off the stack, and then I will check after if we don't want that. So this can be stack.pop. So this is actually the current is going to be that, or starting, I suppose, is more what it is, but then we'll set it as the current. So this can be started. And then we can do target is stack.pop as well. So the one that is just below that. And then we'll make a new loop. So this will be the loop. And then let's see. Yeah, let me do like loop. There we go. That is how I want to define it. And then I can do let's see, loop.starting equals, or hang on, loop.current equals starting. And loop.target equals target. Okay, so now we have all those. And then when we encounter the loop, we want to look at the current loop. So actually, maybe I'll do. Can you have nested loops? You probably can't have nested loops, so I can't really do that. Yeah, that makes it a bit more complicated. So basically, do we need to make a loop stack? Well, for now, I won't allow nested loops, and then I can add that after if I need to. So this can actually just be defined up here. So loop, set the loop there. And then we set the current loop, let's see, right here. And then when we encounter I, we just want to simply, let's see, if is word, and add the else in there. So we can do that if it is not a word. Otherwise, we want to do, let's see, stack.push, let's see, loop.current. That is what we want to push. And then for the loop type, yeah, we can actually add the same check. No, it's too much. If is word, yeah. Okay, so, but we don't want to push here. We want to compare the current and the target. So if loop.current equals loop.target, then we want to break out. Else, we would just want to go back, basically decrement I until it is equal to do type again. So we can do, let's see, and then we can do val dot category does not equal do type. I plus equals something like that. Whoops, that is not what I wanted. There we go. Too many spaces there. Okay. For that, then we will actually decrement this instead of incrementing it. And then that's basically all that we need to do, I think. So we can decrement that. And also we need to increment current. So that current plus equals 1. There we go. And then we basically go back through and do it all over again. So let's see, I think we can do not equal. Get rid of that. And there we go. So let me try to run that. And we get some issues. Loop has no field or current. Yeah, because it is current index. So let me just call it current, because we don't need the index. Okay, so run that. And then undefined index. So that is 370. Whoops, that's not what I want. 370. There we go. Okay, so index. This needs to be a declaration. Okay. So we print out 0 and then it stops. So that is not good. So we are not incrementing it properly. Oh, because we're not setting val here. So we need to do val equals opens up. Okay, stack underflow. So that did break it. Okay. So maybe we need to do I++ after this thing. Okay, there we go. We printed out 0, 1, 2, 3, 4, 5. So actually, I think we want to do, we don't want to print the last one. So we need to iterate this one less. Loop.target minus. Or actually, I think we can just do, so it increments. So this needs to be is less than that. And then when we run it, okay, no, it still hasn't worked. Stack is 1 extra. So, we've got target minus 1. There we go. So that is expected behavior now. So let me make this 10, and then it should print 0 through 9. Perfect. And this can start at 4, and then it should print 4 through 9. Okay. And we should be able to do other stuff here. So push a 10 rather than the I. 10, 10, 10, 10. Okay. And not print do I at all. And it still works. But it doesn't in this case. So let me actually grab this. And instead of pushing I, let me push 10. Then does it work? Okay, so yeah. So you just have to do something within the loop. So that was the issue. So yeah, there we go. We have do loops, it would seem. So I can go up to like 100 and start at 1. And then in here, I'll just print something, and it should print that 100 times. That's probably too many. So let's do that. Yeah, and then we can add a new line as well. And then something, 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 something. Okay. That is pretty cool. So yeah, loops. And then you can make them conditional by using the if statements as well. Yeah, so we could, let me try implementing this exact thing that they show on the website here, and then it should work. So fizz, 3 mod 0 equals dupe if, fizz, then, and then buzz is 5 mod 0 equals dupe if buzz, then, and then fizz buzz. So if it doesn't work, then yeah, that'd be not very good. But swap buzz or invert. Okay, need a space there, and then do fizz buzz. Do fizz buzz. 25 do CRI fizz buzz. If I dot then loop, and then do fizz buzz. Okay, so let's see what happens when I try to run this. And nothing happened. Okay, so it didn't work. Did I mess something up in the declarations? Perhaps. Let me just compare to this and make sure it is working. It is typed properly, and then I can figure out why it didn't actually work. So fizz buzz. Okay, so this is the loop. And then this is a new line, and it prints I. Fizz buzz. So dupe fizz. That's what we want. Swap buzz or invert. Buzz. So that's just checking if it's equal to buzz, and that should work fine. Equals dupe if buzz then. Okay. So let me just call, just push like 3 and then call fizz. And it does print fizz. Okay. And then if I put buzz, it shouldn't print buzz. It prints fizz though. Oh, you know what the issue is? I didn't actually push anything. No, I shouldn't have to. So, yeah, I don't know what that deal is. So, if I actually call buzz, what happened? Okay. Stack underflow. Yeah, because there's nothing on the stack. So, if I push a 5, it prints buzz. But if you push a 3, it prints fizz. So that's kind of weird. Why is it printing fizz when we call buzz? What if I just push 3? Then it doesn't call anything. So, buzz is for some reason calling fizz as well, which is not, it doesn't look like it should be doing that, so I don't know why. Do fizz buzz. What if I do something like that? So we don't get anything. Okay, fizz buzz. So what if I put like 10 there? Then we get nothing. So a 9, nothing as well, and then 8, it should be something. So it doesn't print anything. Okay. So that's just actually checking. Okay. Yeah, so that, it doesn't want to print anything. So, yeah, so I think there's an issue in here, but also maybe in there. Okay. Fizz. What does that do when you do 5 in the fizz? Like that. Run that. Yeah, so that doesn't print the buzz, but the fizz prints the buzz. And that's kind of strange. What is buzz? Buzz prints buzz. But it shouldn't actually in that case. So that is not quite right. So I think, okay, this could be an issue in a couple different places. And because there's no air handling, it's pretty hard to actually check. Yeah. So, well, let's just start. Let's start on the fizz. So let's just add some debug statements. Specifically in the word, in here, let's just print the word. So, let's see. Let's see, we're doing that up here. So this is where I want to print. Val.value. Okay, so if I print that, then, alright, so here's everything that we get. Fizz. Alright, so, yeah, it looks like it doesn't stop the declaration. No, because this is actually all the definitions, so it should be, so let's actually print this in a different place. If I go down here, when we encounter a word, let's see, where is that at? Word type. Right here, let's print that stuff. So we get fizz. So that is working. It is just calling fizz. And that's what I wanted. So, Okay. Let's do if in word. Just in the loop here. We'll do if is word. Then we will print the value. So then we'll just see when we're calling. And that doesn't work because val is undefined. Because that needs to go right under there. There we go. Now if I run that, 3 mod 0 equals dupe if is then. Okay. So that is because it prints it out. So yeah, it's not, it doesn't have any of the other tokens. So what if, yeah, so why does it print fizz then? That is quite strange. Because it's not part of the word here. So do I need to actually, let me just do all this in here. And then see what actually happens. Okay, so that is expected behavior. Maybe if I actually copy this from here. Whoops. Okay, so there's a space there. And then, so yeah, I forgot you're supposed to put 2 spaces there, but it doesn't actually make a difference. But it's just like idiomatic or whatever. So we have fizz. Yeah, all that looks fine. Buzz. Okay. Oh yeah, this is the same thing. So I need to look at that actually. But yeah. So that should be fine. If I run this now. Actually that makes sense to print fizz. Yeah, I'm kinda okay. But what if we call buzz? Then what is it? That is actually what I want to know. Okay. So it prints out fizz there. So yeah. Okay, so it contains the same thing. So there's an issue when we have multiple function declarations. Cause yeah, it just combine them together essentially. Because here's the fizz, and then there's the buzz. So, yeah. So, there's an issue somewhere in here. Oh, it's because, yeah, we need to actually reset word tokens. So, can we just do this, and then do word tokens equals, let's see, how do you do clear array in, yeah, that is what I need to, I basically need to clear an entire array. Is there like a good way of doing that? Clear entire array and go. That is what I want to do. Setting it to nil, so that's not what I want. Ooh, okay, actually, yeah. Okay, so here we can do equals word tokens like that. There we go. So now if I run that, okay. So that is not right now. So why does it do that actually? If I okay. And buzz, yeah, buzz doesn't work anymore. Well actually if we do 5, does it work? No it does not. So that is an issue. Yeah, basically maybe this isn't where we want to clear it. So whenever we're declaring a new word, we want to actually reset it. So maybe that should be done down here. When we encounter, let's see, it is a colon type. Yeah, so that's what we want, right? Colon type. And set that equal to that. Okay. So, if I run do CR. Okay, so it doesn't have the print though. So that is a tag string. That yes, I about that one. Yeah, so I think I broke everything now. So that's kind of funny. Yeah, so that still doesn't work. My fault is buzz. Actually it needs a question mark. Then we get a lot of stuff here. So what if I push a 3 on here? Let me get rid of that print statement, and then I can see what it's doing, what it is doing. Yeah. So, it prints out every number from there to there. So, 24. So yeah, but it doesn't print the Fizz version. So that I think is an issue. Ooh, and then whenever we call Fizz, it does that as well. Call Buzz, does it do? It doesn't do anything. So yeah, why does Fizz have all that though? So it is appending all these things. So it doesn't actually stop. Okay. Uh-huh. Maybe word tokens needs to be reset in here instead. I just need to find the right place to do it. So maybe it is not there. Right here. Let me try it. Up here. Yeah. Try putting it right there. Yeah, so it still doesn't work. The issue is it because of the way that we're doing it. So what if we do yeah, basically word tokens like that equals nil. Alright, so that doesn't work. Let's see. So what is the ideal way to do this? So dump. So dump will do that. Then so that dumps them all. So okay, you can just set it equal to nil. Will that work? Okay. That looks actually a lot better than Buzz. Okay, so Buzz isn't quite right. Buzz is the wrong one. And what if I put the Fizz Buzz? Yeah, and then that still doesn't work. So the first one works now, but not this one. So this just grabs the entire thing. Ooh, because we have nested calls, I think is what causes that. So, okay, so why does Buzz not work? If I just get rid of this entirely, what does just Buzz do? Like that. Okay. So Buzz actually looks fine. Yeah, Buzz actually works fine. But if I put them back, then it does not work. Yeah. So when you define new ones, it is messing them up, essentially. So, that is not good. So, I need to do something about that. Okay. Okay. So is it because it has the same name? Is that the issue? So what if I change the name to is us, and then make this is us, and make this just something. Let's see. Is it name conflictions like that? Let's see. So Buzz, no, Buzz still doesn't work. What if I call this another? Yeah, so it is something, I'm assuming with this. So if I get rid of that, I get rid of that, then it works. Okay, so it is something with calling them from in there. So this is why you test. Yeah. Okay, so in the word, when we encounter a word, we're setting the current word equal to that. Okay. So, let's see. Give me 1 second. Okay, so let's see what we have to do here. So if we're in the word, then we're setting the current word equal to that. So I think that is the issue. Yeah, so maybe we can't do it like that. Because when we call this, we're inward. So that basically doesn't allow for nested calls. Yeah, because now buzz works. Dupe is swap buzz. Question marks throw me off. Okay, so when we call that, it breaks. So dupe swap or word. Yeah, so when we're in word, we just want to so if inward, but we're never inward if we're in here, right? Yeah, because that's inward. So that is not what the issue is. It is something, it's a different way it is interpreting it. So, okay. So, interpret tokens. So we're calling it with the words. Okay. So that should just expand it there, but it doesn't do that. Let me print here. Not that. So what do we get when we do that? So we get buzz. Buzz. Let me get rid of this call and see what happens. So yeah, nothing happens. Because we're just adding the definition for it. Oh, so buzz, it just prints out buzz. Why does it print buzz? Oh yeah, because we're in a word. Okay, so, because that is a stack underflow, right? Yeah, so that breaks. So I need to put some here, like that. Then it does that. So yeah, the word that we encounter is buzz. And then we go in here. So basically we're changing the value in the hash map of this. Ooh, okay. Actually, I think I know what's happening. So in here, we encounter this. We encounter a word type, then we're setting that, and then we're updating that in there. So that's not what we want to do. So, when we encounter, let's see, when we encounter, it is a colon. That is down here, colon type. And we set in word equal to true. And then on the next iteration, so it's going to index +1. So basically in here, we can just do current word equals that. And then just not have this check at all. So if I get rid of that entirely, and then run this, buzz is what we print out. So yeah, but then there's nothing in there. Okay. Let me get rid of that. So yeah, nothing happens now, which is not what we want. So it is still clearing it. What if we call fibs? It prints out nothing. And it still does what we do that. So that does break stuff. So current word equals that. So then let me just format that print line, current word. And then see what it is. So what is the first current word? Ooh, okay, so this actually goes around a bunch of times. So we just want to do this on the first iteration. Okay, so that makes it a bit more complicated. Maybe we could actually set that. Yeah, that's not gonna work though. So yeah, let's do it before the loop. Let's do current word equals that. Basically is word. Then we'll set the current word. I guess it doesn't really matter though if there is no word, so we might not need that check. But just in case, undefined value is that. Okay, so yeah, let's just do tokens I like that. Tokens 0. Okay, like that. And then current word equals, yeah, we need to append it, right? Or no, current word equals token 0 dot value. There we go. And then now we have index outer range 0 with length 0. Okay. So the tokens don't have the right length. Why is the length 0? So when we call it, yeah, so that's not actually gonna work. So yeah. Yeah, the way I was thinking about doing that won't work. So that just sets it to a colon. Yeah, so if we encounter this, we might need to pass the current word. Yeah. I think that's what we're gonna have to do. So let's just accept current word as a string here. And then get rid of that from there. And then we can set current word down here when we encounter a word. Right before we interpret it, we do that. Current word equals val.value. Val.value. Okay, and we can pass current word here. Current word. Okay. No, that's not exactly how we want to do that, is it? Hang on. Well, so let me create a current word here. So let's do where current word string. And actually pass that in here. Current word. So it's not going to work yet. The current word is actually none. So we're not setting it properly because we don't want to set it on the call. We want to set it right here, basically. Right on the next iteration. So, because we're going to iterate it again. And then we'll be up here, and it will be inward. Yeah, so we basically need to set it. We basically need to iterate one more down here, and then go back again. That's sort of what we need to do. So it's gonna look a little weird. But we can do I++, and then do I minus minus. And that should do it. No, maybe we need to do I plus equals 2. Actually, no, then we need to, no, so that was fine. But then we need to actually set val equals sir I. Maybe we could just do sir I plus 1. Actually, yeah, we can do val I, or we can do tokens I plus 1 dot value. Yeah, then we don't need to worry about iterating it like that. And then we get fizz over and over again, and it loops forever. So that is not what we want exactly. So why does it do that? If we encounter current type, then that is the current word. Let's see, where else would we declare the current word? If inward. So we don't actually encounter this, I don't think. Yeah. So now, if I go up here, else do that. Okay. Format our print line, current word. So we just get stuck in an infinite loop here. We'll semi-type. Else if it is that. Else do that. But then we're not iterating I anymore. Okay. Maybe we need to check. Else if now that category equals word type. So if I do that actually, does it not get stuck in a loop? I spelled that wrong. Category. There we go. Okay, so now it's not an infinite loop. We get fizz. It also print something a bunch of times. Yeah, because that's actually the definition. So, that is fizz. So let me get rid of that. And then, get rid of that as well. So it doesn't print anything. But if we make that 9, it should print fizz. And then if I do buzz, see what buzz is. So I do 10 now. Buzz, okay. And then, let's see, if I call something, it should, okay, so that's almost right. Yeah, we're almost there. So, unfortunately, I do have to go now, so I'm not going to be able to finish this today. So, I will finish it next time I stream. So, I will just commit this really quick. Let's see. So, added loops and fix a problem with the function. still doesn't fully work, but needs, but almost there, and almost do fizz buzz. There we go. So I'll push that, and then I need to look at something really quick in here. Test.4. We're calling this diff wrong, so it might actually work. If I make this another, like that, then may not go with test.4, then, yeah, so it still doesn't work. So it just prints the iteration. So, let me call this, let's see, what is it called in here? Fizz buzz. Yeah, so that's what I want to call. Like that, and then, yeah, so it doesn't work still. Fizz buzz. So, let's see. What if I just call it fizz buzz though? Fizz buzz. I should. Yeah. So it gets messed up. But if I put a number there, then it doesn't print anything. But if I put 3, it should print. Yeah. So it doesn't. So there is an issue with that. So that's sort of what we need to fix. Next time. Let me make sure it committed properly. Okay, and perfect. So yeah, that's going to be it. Thank you for watching, and I'll see you next time.